Alright, let me just fix some things here. Alright, we're ready to go. This is, what is it, lesson 5? I forgot to put that on there, didn't I? That's okay, I'll put 5. Alright. Alright, there we go. Say what? It is off. Yeah, just 1. Let's see what we're going to do. Alright, let's do this. Fractional exponents. Actually, we're not going to do fractional. What do I want to do here? Yep, let's talk about fractional exponents. For instance, if you had like x to the 1/2, do you know another way to write x to the 1/2? Or actually, I should do it the other way. I kind of, let's see. Let me get started on the right track here. Let's try this. Let's go, I kind of gave it away, but that's okay. If I had the square root of x, there's another way to write the square root of x. And it would be x to the what? Just erased it. What is it? To the 1/2, right. So that would be x to the 1/2. It's the square root. So x to the 1/2 means exactly the same thing as the square root of x. What if I had this? What if I had the cube root of x? You've heard of that, haven't you? The cube root of x? Well, it's not x equals. X to the 1/3. Right, exactly right. It'd be x to the 1/3. Let's just do one more just to get our pattern going. What if you had the 4th root of x? What's another way to write that? X to the what? 1/4. You get the idea? Pretty easy, isn't it? Yeah. Alright, so let's do some problems. And what we're going to do is we're going to change some of these. It might be written as a square root, but anytime it's written as a square root, we can take it to the 1/2 power. It's the same exact thing. Sometimes it's just a lot easier to work with exponents than radicals because there's probably a lot more rules for exponents than there are for radicals. Okay, so that's what we're going to do. So this is x cubed y inside of here, and it's being multiplied by, now this is a 4th root, okay? That little 4 right there, it's a 4th root of xy cubed. Now if I ask you to multiply those things together, now they don't put a dot in there because if there's nothing in between, it automatically means they're being multiplied, correct? So it means multiplication, but I can't really multiply a square root and a 4th root together. There's really no rules with radicals that I can do that. So really about our only option is to take this stuff and take it to a fractional exponent. So if this is a square root, we're going to take all this stuff to what power? To the 1/2 power. So let's do this. Let's rewrite all the stuff inside there again and take it to the 1/2 power. You with me so far? What do you think we're going to do here? We're going to take all the stuff in here. That's x, y to the, that's supposed to be a 3. Looks pretty ugly. That's right. Instead of the 4th root, we're going to take it to the 1/4 what? Power. And we're going to multiply those together. But we're not going to multiply them yet. Look at this. Let's simplify this square root right here. Or this, not square root, but let's simplify this parentheses. It's being taken to the 1/2 power. So that means I'm going to take everything in here to the 1/2. So what are we going to get? What's the rule? Do you remember the rule? Let's go back in time. We talked about this yesterday, I believe, when you asked one of the questions. What if you had x squared times, I don't know, x to the 5th? What's the rule when you multiply exponents together? I know, I'm just making this up. I'm just making this up. Oh, I said squared? Oh, okay, whatever. It's cubed, sorry. X cubed times x to the 5th. So, what's the rule? Yeah, you just add the exponents, right? Remember that rule? Okay, so you just add the exponents, so it's x to the 8th, correct? Let's go down here and just apply the rule. This is x cubed. It's being taken... Oh, actually, you know what? We'll get to that rule in a second. Let's do another rule. What if we did this? What if we had x cubed, right, to the 5th power? What if we actually took it to another power? Judah, what's the rule? Okay, go ahead. What, here? No, I said that. I said it looks like a 7, but it's a 3. I even said that, I think. I made it right here, right? See, I just made it x cubed right here. I even said that. Yeah, you'd multiply these together. All right, so when you have an exponent being taken to another power, right, when you have two exponents like this, one's being taken to another power, you multiply the exponents together. So what would that be? That would be x to the what? 15th. Okay? You recognize those rules? Okay, they're basic rules. Yeah, Algebra 1, you learn those rules. So let's go back and do this. I'm taking everything in here to the 1/2 power. So it's x cubed to the 1/2. It's an exponent to another power. What do we do with those exponents? We multiply them together. To the 6? No, come on. It's 3 times a half. What's 3 times a half? What? Yeah, I'm not going to write 1.5. Just do it. Just multiply straight across. Come on. Multiply straight across. 3 times 1. 3 over 2. Right. We're going to write it as 3 over 2. We're not going to write it as 1.5. We're not going to write it as 1.5. We're going to keep it as just one single fraction. Okay. If it happens to come out to be a what's the word? Goodness. No, not a mixed number, but a improper. If it comes out to be an improper fraction, we just keep it an improper fraction. Don't ever put an exponent as 1.5 or 1.5. Don't do that. It's too hard to work with. All right, keep it as there I go again. Here's my brain. What is it? Improper. Gee whiz, why can't I think of that word? Improper fraction. So what is this going to be? It's going to be x to the what? 3/2. Let's do the y. Look, this is y to the first, isn't it? What do we do with the exponents? Multiply them together. So what's 1 times a half? It's just 1/2. You with me? Look at this. Let's do this one over here. This time, everything in this parenthesis is being taken to the 1/4 power. So if it's just x to the first, x to the 1/4. What about the y? What's y cubed to the 1/4? What do I do with that 3 and that 1/4? Multiply them. So Jacob, what is it? 3/4. Right. It's y to the 3/4. You just multiply straight across the top, straight across the bottom. It's 3 over 1 times 1 over 4. Everybody see that? 4 is on the bottom, the 3 is on the top. Multiply across the top, across the bottom. It's 3/4. Are we finished? No, we took everything, because this problem says to simplify. Yeah, we don't want the 2 x's there, we just want 1 x here. Now we're going to apply this other rule that we learned up here, right, that we probably learned in Algebra 1. So let's do the x's. It's x to the 3/2 times x to the 1/4. So what do you do with your exponents? What do we do with these exponents, this 3 and this 5? We added them up. So what are we going to do with 3/2 and 1/4? We're going to add them up. Watch, I'm going to add those up off to the side. Now look, I can't look over your shoulder at home and make sure you're not using a calculator, but I want you to learn how to add these fractions without a calculator, all right? So every time I do this, I'll never use a calculator to add these fractions together. I'll only use a calculator to do like real long decimal type numbers and stuff like that. All right, but let's find this. What's the common denominator here? It's 4. So 2 times what? 2. So 3 times 2 is 6 plus, that didn't change, 1. So what is it? 7/4. Don't change it to a mixed number. Don't change it to a decimal. Keep it 7/4. So my x is going to be x to the 7. That's ugly. Let's try to make that look right. X to the 7/4 power. All right, make it small. Make it above. That's probably a little bit too big, but it's x to the 7/4 power times. Let's do the y's. So let's take the y's. This is still a multiplication problem, but what are you doing to the exponents? You're adding them together. So let's take those two numbers and add those together. So what do we have? We got 1/2 and we have 3/4. So let's add those fractions together. Common denominator is 4. 2 times 2, 1 times 2. Then 4 doesn't change, so the 3 doesn't change. So that's 5/4. All right? So it's y to the 5/4. And that is how they want you to write the answer.
Will you always have the same common denominator?
I mean, you always have to find a common denominator. Oh, for this? No. I mean, the y's could have been something completely different. No. It just happens that these both have the same common denominator. Now, we can't do anything with these, can we? We can't add these together because, look, this is an x and this is a y. You can't combine them any other way. That's all you can do with it right there. All right? So basically, we learn these rules. And I'm telling you, these rules show up all the time. You wouldn't believe how much you got to know these rules. So when you multiply with the same base, right? When you multiply numbers that have the same base and they have exponents, what do you do with the exponents? Keep the base the same and you add the exponents. If you have a base and you have to an exponent and that's to another power, okay, a power to another power, you multiply the powers together. So that's x to the 15th. These get a little bit more complicated because they're fractions, and people see this and they just recognize, oh yeah, I know what that is, with hardly thinking about it. But when you see fractions, it doesn't always just pop in your head, does it? You got to think what the rule says. The rule says you have to add the fractions together. So you take the numbers with the same base, and then you just add their exponents. You take the numbers with the same base, with the y's, you add those exponents. I just do them off to the side, and you can do it right here. You with me? All right. Let's go to another kind of problem. Same deal, same rules, all right, but a little bit trickier. All right, this one looks a little uglier, doesn't it? All right, now we've got a fraction, right? We've got a division, but that's not that big of a deal because we remember what to do. Let's go back in time a little bit. Do you remember if you had x to the, I don't know, 7th over x to the 3rd? What's the rule for these? If they're the same base, what do you do with the exponents? Subtract the exponents. Okay, so it's x to the 4th. Or if you wanted to, some people like to do this. They like to take this number that's on the bottom, flip it to the top. If you flip it to the top, it's going to be x to the negative 3rd. And then you just use the rules for multiplication. Add the exponents this time. 7 plus negative 3 is still a 4. There's times when you want to flip it, top or bottom. There's times when all you want to do is just subtract the exponents. It just depends on the problem, the situation. Okay? So let's take a look. First thing we want to do here. Let's not mess with the a's just yet. Okay? I see this parentheses and I see this exponent. So what do we do with the exponents? This is an exponent. That's one big exponent, 2 minus x, and is being taken to another exponent. So what do we do? You multiply them together, right? So with the a's, let's just keep the a's where they are. We'll mess with those in a second. So it's a to the x over 2. And now we got to multiply these together. Watch, I'm going to have to take that, multiply it by that 1/2. Can you do that in your head or not? It's basically 2 minus x times what? A half. Let's do that. What's half of 2? It's just distribute. It's 1 minus half of x is 1/2 x, but we're going to write it x over 2. All right? I do this off to the side so I don't mess up this problem so much. Okay? So watch what we're going to have. We're going to have y as my base, and look at my exponent. That right there is going to be my exponent. It's a little ugly, but we can work with it. 1 minus x over 2. Good so far? That's all I've done. I just simplified this thing right here and nothing else. Let's keep that x down here. That a, I'm sorry, a to the 3x power. And then the y, this is to the negative 2x power. It depends on what you want to do here. You could just subtract the exponents. That's fine. Okay, so it would be 1 minus x over 2 minus a negative 2x, which would just be the same as what? Minus a negative would be the same as doing what? Just adding, right? Okay, so you could do that, or if you wanted, you could take this, toss it up to the top, and that's going to be y to the what? 2x. It'd still be the same thing, wouldn't it? Because it's going to be 1 minus x over 2 plus 2x. Either way you do it, it's still going to be the same. So let's come down here. 1 off to the side, 1 minus x over 2. And what are we going to do with that? Plus 2x, correct? I'm going to put it over 1. Why? Because I have a common denominator. See that? So really, all I'm doing is just adding these two things right here. So it's going to be a 1. What's my common denominator here? Come on, talk to me a little bit so I know you're paying attention. What's my common denominator? I got a 2 and a 1. What's my common denominator? It's 2. Did I do anything to this to change it? No. So that just stays minus x. What's this going to be? 1 times 2. So I multiply that by 2. What does that give me? 4x. Okay? So let's keep going. It's 1. What's this going to be? Negative x plus 4x. What's that? It's 3x. Over what? 2. That's the way we're going to keep it, just like that. You with me? Yeah, that's the way I do it. They write it different in the book. I would do it like this. This is how I would do it. So that's your y's. So our answer would be y to the 1 plus 3x over 2. Alright, so I've taken care of the y's. Now what do I have to mess with? The a's. So let's play around with the a's. Jacob? Oh, I am. Thanks. I better stop.